In this video, we will show how the Heroes platform executes the workflows and the containerization of the software. Executing the workflows efficiently in a reliable software platform is one of the main goals of the Heroes project. Because of that, a prior investigation of case studies that can take advantage of our solution has been done. Considering their different steps in the execution and their individual computational needs, this has driven us to the conclusion that the most representative use cases are computer-aided engineering and artificial intelligence, which were used as case studies for the development of the platform. Another fact to consider is the reproducibility of the software used. If the user is running the same program in different places, we should ensure that it remains immutable. This is possible by containerizing the applications and moving always the same version to the required clusters. Complex workflows include different steps with diverse computational needs. In the slide, we show an example of a computer-aided engineering workflow. It starts and ends with interactive services, which require the action of the user. The intermediate steps will be executed automatically by the platform according to its needs. High memory requirements for preprocessing, high parallelization for the solver, and a powerful CPU for the post-processing step. The computational resources needed to execute those steps in the most efficient way are not always located in the same facilities. Heroes platform allows the user to select the most appropriate facility to run each step. Here is an example of how the workflows work in Heroes platform using a customized version of Nextflow Workflow Manager. In the example, we show two steps of the same workflow, one which requires extra memory and a second one which needs more computing power. Nextflow configuration file, which is written transparently by Heroes, specifies the cluster and the data storage server to be used on each step and manages the job submission and the data transfer between processes. In the schema on the right, it can be seen a process called memory intensive, which is executed in a cluster located in Northern Europe, followed by a process named CPU intensive executed in Southern Europe. The data generated on each step will be stored in the same external storage server managed by Heroes, and the temporary data will be removed from the physical nodes. Due to the innovative ideas behind the Heroes platform, no tool was readily available tools to be directly plugged into the architecture. However, there are open source tools which can be adapted by our own, and it is the case of Nextflow. Nextflow Workflow Manager executes the different tasks inside a workflow sequentially or in parallel, taking care of the data transfer of inputs and outputs during the process. As we are using different clusters located in different places during the workflow execution, and it is a feature not covered by Nextflow. One of our tasks was to adapt the code to take into account the co-location of resources. That includes secure connections to remote cluster, transfer of software containers, data and messages. Additionally, the call of the executable by the job scheduler needs some tweaks, starting with the definition of environment variables needed by EAR, the energy-aware runtime library that will record the power consumption of the jobs, and additional metrics. In the slide, we show the different parts we have included. First, a bind mount must be done to consider the work directory in and out the container, plus the paths of EAR installation and temporal folder. Then, we define container image file, followed by the command to call EAR, which includes the path to the executable. Applications inside Heroes platform are provided containerized in Singularity image files. The reason for our choice is to easily apply the same software stack on each step of the workflow, thanks to the Singularity image file container format. SIF files can be tracked using cryptographic signatures to ensure that the image was not affected during the file transfer due to packet loss or an intended attack. Additionally, using Singularity over other containerization tools allows the user to run the container without privileges, ensuring the safety of the external clusters. Singularity definition files were built taking into account the considerations of the community. For example, the definition file needed to generate the OpenFOAM container downloads the software stack from the web page of the organization that provides it. It then compiles and installs it according to the recommendations of the experts. As the time to build the image takes some time, the Singularity image file is built and shared among all the servers where it is required. A complete execution of a workflow using a Singularity image file encapsulating the software is presented in the next video. This is a demo of how a workflow is run outside the Heroes platform. Nextflow input file defines a pipeline with 3 steps: unzipping the input, executing a memory-intensive step, and a second execution of a CPU-demanding step. All 3 processes are called sequentially. Each step can be executed in different environments with a diversity of options. In the screen, we can see the cluster variable which was added by Heroes to define where the process will be executed. The first 2 steps will be run in the main cluster, and the last one in the cloud cluster. For each step, different memory and CPU requirements can be set. With the Nextflow input file and its configuration, we are ready to launch the pipeline. In this case, we will use a Singularity container including the software. The work directory can also be defined as an optional parameter. Later, we can specify the configuration. To follow the execution, we will show the 2 clusters where the pipeline will run, main cluster at the top and cloud cluster at the bottom. The first process runs relatively quickly, jumping to the next one in just a few seconds. The second step starts without manual intervention in the first cluster, as we can check in Slurm Workload Manager. Inputs, intermediate data, and outputs will be stored inside the work directory specified in the command line call, properly ordered according to the enumeration shown for each step. Let's check what is inside the work folder of step 1. Notice that the motorbike tar file is decompressed, as we asked for in the input file. Jumping to the output folder of the second step, we can see how now is the motorbike folder the one that is linked. As the complete execution of the workflow takes a few minutes, we will jump to the finalization of the second step. As you can see on the screen, the third step, which is related to the CPU demanding process, starts in the cloud cluster as specified in the Nextflow configuration file, just when the second one is completed. Once it is done, all the data generated during the workflow will be safely stored in the Minio folder of the organization and removed from the remote nodes. In this presentation, we reviewed the workflow definition, the changes done to Nextflow code to adapt it to the Heroes platform, and our containerization strategy. Thank you for your attention, and do not hesitate to contact Heroes Tim for any question.